Scene script. Imagine a civilization so advanced it can harness the power of a star. Is this the future for energy needs? As we look around us, we see how the world is powered by energy. From the smallest microorganisms to the largest cities, everything requires energy to function. This energy is derived from various sources, many of which are finite and fast depleting. As our civilization advances, our energy needs increase exponentially. We're developing technologies at a rapid pace, creating a world that is more connected, more efficient, and more reliant on power than ever before. This energy consumption isn't just about turning on the lights or powering your smartphone. It's about sustaining life, advancing technology, and exploring the unknown. It's about powering the future and ensuring the survival of our species. But where does all this energy come from? Currently, we depend heavily on fossil fuels, coal, oil, and natural gas. These sources, while abundant, are finite and contribute to environmental degradation. Renewable sources like wind and solar are promising but still lack the efficiency and scale required to meet our growing demands. This brings us to a fascinating scale proposed by Russian astrophysicist Nikolai Kardashev in the mid-20th century. Known as the Kardashev scale, it classifies civilizations based on their energy consumption. A Type 1 civilization, also known as a planetary civilization, can use and control energy at the scale of its entire planet. A Type 2 civilization, on the other hand, can harness the power of its local star. And a Type 3 civilization can control energy on the scale of its entire host galaxy. As of now, we're not even a Type 1 civilization, we're somewhere around 0.7 on the Kardashev scale. But as our energy needs continue to grow, we're forced to look beyond our planet, beyond our solar system, and even beyond our galaxy. This leads us to an intriguing concept, the Dyson Sphere. A Dyson Sphere, a hypothetical megastructure, is an audacious solution to our energy problems. Imagine, if you will, a colossal structure of incomprehensible scale, built to encapsulate an entire star. Not just any star, but our own life-giving furnace, the sun. This is the concept of the Dyson Sphere, an idea so vast and ambitious it stretches the very boundaries of our imagination. The Dyson Sphere is not a solid shell, but rather a swarm of satellites orbiting in a dense formation around the star. Each satellite is designed to collect the star's radiant energy, converting it into usable power. This swarm, collectively, forms the Dyson Sphere, a megastructure designed to capture as much of a star's energy as possible, leaving virtually none to waste. The concept of a Dyson Sphere comes from the brilliant mind of Freeman Dyson, a renowned theoretical physicist and mathematician. In the 1960s, Dyson proposed this idea as a potential solution for advanced civilizations facing an energy crisis. He imagined a future where our energy needs might outgrow what our planet can provide, and in that future, he saw the untapped potential of our sun. If we think about it, our sun pours out an enormous amount of energy every second, most of which just goes into the void of space, unused and wasted. Dyson's idea was to harness this energy, to put it to use to fuel our civilization. The Dyson Sphere in this context is not just a solution, but a necessity for any civilization looking to become truly interstellar. The concept of a Dyson Sphere is a testament to human ingenuity and imagination. It forces us to think big, to dream beyond our current capabilities, and to envision a future where we can harness the full power of a star. Sounds like science fiction, doesn't it? But could it be our reality? Building a Dyson Sphere is no small feat, it's a project of astronomical proportions. Imagine a construction project on a scale unlike anything we've ever attempted. A Dyson Sphere is not just a megastructure, it's a gigantostructure, dwarfing even the largest of human-made constructs. To put it in perspective, we're not talking about building a skyscraper or a city or even a continent. We're talking about building a shell around an entire star. The first challenge is material. We would need a staggering amount of matter to construct a Dyson Sphere. Theoretically, we could dismantle a planet, say Mars or Venus, for raw materials. But even then, we're scraping the bottom of the barrel compared to the sheer volume of a Dyson Sphere. The technology to accomplish such a feat is currently beyond our reach, but who knows what the future holds? Next, consider the engineering challenges. We need to build a structure capable of withstanding the intense heat and radiation of a star. It must also be stable against gravitational forces and able to maintain its position relative to the star at all times. The design and construction of such a structure would represent an unprecedented feat of engineering. There's also the question of time. Even if we could somehow accelerate the process, building a Dyson Sphere would likely take centuries, if not millennia. And that's not even considering the time needed to collect the necessary resources. Finally, there's the issue of logistics. How do we transport materials, machinery, and personnel across the vast distances of space? How do we coordinate the efforts of countless workers over such a long period of time? These are questions we can barely begin to answer. But let's not forget why we're considering this in the first place. A Dyson Sphere would offer virtually unlimited energy, capturing the full power of a star. This could sustain an advanced civilization for billions of years. The magnitude of this project is astounding, but so are the potential rewards. Harnessing the energy of a star could propel a civilization to heights unimaginable. Imagine capturing the output of a star, every photon of light, every joule of energy. A Dyson Sphere could do just that. But what does that mean in practical terms? Our Sun, a relatively average star, outputs nearly 400 trillion watts of energy. That's every second of every day. To put that into perspective, the total energy consumption of humanity in the year 2022 was a mere 174,000 terawatts. If we were to harness even a fraction of a star's energy, we could power our civilization for millennia. Now let's paint a picture of the possibilities. With the energy of a star at our disposal, we could achieve feats of science and engineering that seem like pure fantasy today. Interstellar travel, for instance, would no longer be a dream of science fiction. The energy required to accelerate a spacecraft to near light speeds would be a drop in the bucket compared to the energy output of a star. Furthermore, artificial environments could be created and sustained with ease. Imagine building entire worlds complete with atmospheres and ecosystems powered by the energy of a star. The potential for colonization and exploration of the cosmos would be limited only by our imagination. Additionally, the energy output of a star could provide the resources necessary for advanced computation and data analysis. We could create supercomputers capable of processing information at speeds and scales currently unimaginable, unlocking new realms of scientific discovery. And of course, let's not forget the most basic and immediate benefit: unlimited clean energy. With the power of a star, we could eradicate energy poverty, reduce greenhouse gas emissions, and usher in a new era of technological advancement and prosperity. With such power, the stars are no longer out of reach. With the power of a star at our disposal, we could become an interstellar civilization. Picture it, a future where we are no longer bound by the constraints of our tiny blue planet, but free to explore the vast expanse of the cosmos. The Dyson Sphere, this marvel of theoretical engineering, could be the gateway to such a future. Harnessing the energy of an entire star would provide us with resources beyond our wildest dreams. Think about it. The Sun, our star, unleashes energy at a rate of about 400 trillion watts. That's more energy in 1 second than humanity has used throughout its entire history. With such an overwhelming power supply, we could fuel our journey to the stars. Imagine, we could send out fleets of spacecraft, each one a self-contained ecosystem, a miniature world, carrying the seeds of life to scatter across the cosmos. These ark ships, as we might call them, would be vessels of exploration and colonization, allowing us to establish human colonies on distant worlds. Think about the technological advancements that could be powered by a Dyson Sphere. With virtually limitless energy, we could develop propulsion systems that defy our current understanding of physics. We might even crack the code of faster-than-light travel, turning science fiction into science fact. Yet, it's not just about exploration, it's about survival. As our sun ages, it will eventually render Earth uninhabitable. A Dyson Sphere could buy us the time we need to find new homes among the stars. It could ensure the survival of our species, and perhaps many other species that share our world. The possibilities are endless. Our understanding of the universe, of our place within it, would be radically transformed. We could become not just observers of the cosmos, but active participants, shaping our own destiny among the stars. Indeed, with the power of a star in our hands, we could become an interstellar civilization. As we gaze up at the night sky, we could look not just at distant points of light, but at potential new homes, new worlds to explore and understand. The universe could become our backyard. The Dyson Sphere represents a future where energy is no longer a limiting factor. In such a future, the concept of energy poverty would be as archaic as the horse and buggy. No longer would we see communities around the world deprived of the basic necessities of modern life. Electric lighting, heating, clean water. The vast energy collected from an entire star could be harnessed to power a civilization beyond the constraints of our current imagination. Think about it. energy is the lifeblood of any civilization. It drives our economies, powers our homes, and fuels our technological advancements. With the near limitless energy provided by a Dyson Sphere, the possibilities are truly astounding. But it's not just about the quantity of energy, it's also about the quality of life. Unlimited energy means the end of polluting power sources, the end of the smog-filled skies and the acid rain, the end of the climate crisis. We could enjoy a cleaner, greener, and healthier planet. Moreover, the sheer magnitude of power harnessed from a star could spur unprecedented technological advancements. The energy necessary to power megastructures, hyper-fast transportation systems, even interstellar travel would be at our fingertips. We could become a true spacefaring civilization, exploring the cosmos, colonizing other planets, and perhaps even encountering other life forms. It's an audacious vision, no doubt. But isn't that what the future is all about? Pushing boundaries, dreaming big, and reaching for the stars, quite literally. The Dyson Sphere, then, isn't just a solution to our energy needs. It's a gateway to a future where we're no longer bound by the constraints of our planet or even our solar system. It's a testament to the boundless potential of human ingenuity and the enduring spirit of exploration. The future is bright, quite literally. But how close are we to building a Dyson Sphere? That's the question that has been lingering in your mind, hasn't it? We've talked about the energy conundrum, the power of a star, and the future of energy. We've introduced the idea of a Dyson Sphere, a colossal structure that could encapsulate a star and harness its energy. But what does it take to build one? In terms of our current technological standing, we are admittedly far from being able to construct a Dyson Sphere. This is a project on a scale we've never attempted before. Building a structure that would completely encompass a star would require a level of engineering and material science that is currently beyond our reach. The astronomical challenges involved in such a project are staggering. Imagine trying to build a structure that is not just massive but also stable enough to withstand the gravitational forces of a star. Now think about the logistics of transporting the necessary materials to the construction site and then assembling them in the harsh environment of space. It's a Herculean task, to say the least. And then there are the timescales. Even if we had the technology and resources to start building a Dyson Sphere today, it would likely take centuries, if not millennia, to complete. This is a long-term project, one that would span generations. However, just because something is difficult doesn't mean it's impossible. Our technology is advancing at an unprecedented rate. Who knows what we'll be capable of in the next 100 or even 1,000 years? We must also consider the potential benefits. The energy harvested from a Dyson Sphere could power an entire interstellar civilization, opening up new possibilities for exploration and colonization. The rewards could be immense, making the effort and investment worthwhile. Perhaps it's a dream for now, but one day it might just be our reality. Let's continue to dream big, to push the boundaries of what's possible. After all, that's how humanity has always advanced. The Dyson Sphere, a testament to human imagination, might seem far-fetched today. Yet, it represents a potential solution to our ever-growing energy needs. Throughout this exploration, we've discovered the concept of this colossal structure, capable of harnessing the power of an entire star. We've discussed the monumental task of building such a sphere, a feat that would require untold resources and technological advances. We've also touched upon the implications of a Dyson Sphere for an interstellar civilization. The energy gleaned from a star could fuel unimaginable advancements, potentially propelling us into a future that today exists only in science fiction. We've pondered the reality of executing such an ambitious project, weighed the challenges and the potential rewards. As we look to the stars for answers, who knows what the future holds? The Dyson Sphere, a dream today, a reality tomorrow.